Hi everybody, Mr. Bozaday here. Today I am going to talk to you a little bit about, or right now I'm going to talk to you a little bit about something we call proportional reasoning. And proportional reasoning is when something in a situation changes and you want to know how that changes something else. Okay, so for example, today we went outside and we did a little activity or experiment where we launched something up in the air. And so what we want to know is, like, imagine that we launched something up in the air and it reached this height. So this kind of like Y final, that apex right there. What would happen if instead of launching that same object up with the initial velocity that we originally launched it up with, what if we launched it up with 1/2 the initial velocity? How high would it travel now? What would be the new Y final? Question mark, right? And so that's what I mean when I say, what happens if we change one thing? How would that affect something else? And that's proportional reasoning, okay? What we've done here is we've listed out some steps to kind of help you with that. And so the first step down here is to identify an equation that relates the two variables and none others that change. So let's make sure we're clear on the two variables that we're trying to relate. Well, the two variables we're trying to relate are v initial. If we launch at a different velocity, in fact, we're clearly saying 1/2 the initial velocity, how will that affect our Y final, our final height, right? So, and what we do is we write a little proportional reasoning sign in there, and this alpha symbol is kind of saying, how do those two things relate to each other? And that's going to be our goal. We're going to figure out how those two things relate to each other. So the first thing we need to do, like I said, is identify an equation that relates those two. All right, well, right away we can see the second equation is not going to work for us, because the second equation, while it has the initial velocity in it, it does not have Y final anywhere in there, right? So this guy does not relate the two, so it's not going to work for us. The first equation we can see could possibly work for it. Sure enough, it's got initial velocity and it's got final height or final position in the Y direction. But we also see the third equation could work for us. We see it's got initial velocity and it's also got final height or Y final position in the Y direction in it. So now we got to figure out which one could they both work? Can only one work? We got to think about that. Well, you may have noticed there was another twist to step one. It says identify an equation that relates the two variables and none others that change. So what we need to do is we need to look at these two equations and ask ourselves, is anything else going to change if we launch our object up at 1/2 the velocity? Well, let's see. Our initial position is not going to change because it's still going to be launched from the same height or location no matter how quickly, no matter what the initial velocity is. So that's fine. Acceleration is not going to change because the acceleration due to gravity, as we talked about in our lab the other day, is -9.8 meters per second squared, no matter the mass, no matter if it's going up or going down or whatever. So as long as we're in free fall, acceleration is -9.8. But the time, that would change, right? If we launch something up with 1/2 the velocity, then it's going to be in the air for less time. So in this equation, the initial velocity would change, the height would change, but so would the time. And that means that something else changes. Remember, we want to identify an equation that relates to two variables and none others change. So hopefully this one's going to work for us down here. So I'm going to cross out that top one. So let's see. Again, we want to relate these two things, the initial velocity and the height. If we change the initial velocity, would the initial position change? No, that's going to stay the same. We're still launching it from the same position. How about the acceleration? Would that change? No, that's -9.8 meters per second squared as long as we're in free fall. What about the final velocity? Would that change? Well, let's see. We're talking about at the max height, which is the apex. That's what we're talking about for the final moment in time. And at the apex, the final velocity is 0, regardless of how high it goes. So that's not going to change. We could launch it at the full velocity, 1/2 the velocity, twice the velocity. At the apex, the final velocity is still 0. So this equation is going to work for us, okay? Now we want to rearrange the equation so that the two variables are on opposite sides. All right. Another thing that you want to do is cross out anything that's a 0. Well, as we just discussed, at the apex, the final velocity is going to be 0. And you can always say you can always put your initial position, set your origin such that your initial position is 0. So let's say that we're making it so our initial position is 0. I'm going to rewrite this equation now so it's a little easier to see. 0 equals v initial squared plus 2a, and then final height, or final position in the y direction. Excuse me. So we got to rearrange this so the two things we're trying to relate are on opposite sides. That's easy. We'll subtract the v initial over. Negative v initial squared equals 2a y final. Okay, now what we want to do is write a statement of proportionality. And that's kind of what I have over here with that alpha sign. So what we see is that the v initial relates to the y final, or the final position in the y direction, by a squared factor. So we're going to rewrite this like so. V initial squared is proportional to y final, or the height. Okay, now we've written our statement of proportionality. Okay, then we're going to insert the changed factor, and we're going to balance the other side. So what we're going to do is we're going to say, okay, in our example, we're going to say the initial velocity is going to change by a factor of 1/2. Okay, so then the question is, so what will the height change by? Well, we got to balance both sides. Well, if the initial velocity changed by a factor of 1/2, then this whole side changed by, here's the trick, the initial velocity is being squared. So if we change the initial velocity by a factor of 1/2, we're also squaring that factor of 1/2. You know, think about it like this. Let's say that we the initial velocity was 4. Well, 4 squared is 16. But if we take 1/2 of that, so then it's 2. So if the initial velocity became 2 meters per second and we square that, it's only 4, okay? So the factor, the 1/2, is getting squared as well. So this whole side changed by a factor of 1/2 squared, or 1/4. That means we need the other side to also change by a factor of 1/4. And so to do that, the y final must change by 1/4. And now we've got our answer. So if we take 1/2 of the initial velocity, that is going to result in the final height changing by a factor of 1/4. So lastly, it's a good idea to write a summarizing statement. And so our summarizing statement would sound something like this. If the initial velocity changes by 1/2, then the object will rise to 1/4 the original height. Boom. And there you have it. That is proportional reasoning. We'll be doing a lot more of that over the next couple of days and the rest of this unit. Okay, thanks for watching. Have a great day. We'll see you later.